This is WKDU 91.7 FM, Drexel University's award-winning, student-run, commercial-free, free-format radio. Good morning. You're listening to 1.6 degrees centigrade, rising, and your critical role in climate change, Philadelphia's newest public information program on all matters impacted by climate change. This is your author and host, Diane Davis, and during this segment, we'll be talking to our expert faculty researcher on air quality, Dr. Peter Decarlo, who teaches in the Civil, Architectural, and Environmental Engineering Department in the College of Engineering and Chemistry Department in the College of Arts and Sciences at Drexel University. Dr. Decarlo's research and teaching interests include measurements of gases and particles in the air that impact both our air quality and climate. Measuring the concentration and composition of gases and particles in the atmosphere improve our understanding of the sources and impacts of these pollutants. Dr. Decarlo will be speaking to us in particular about several of his collaborative research studies undertaken with co-investigators in the Commonwealth. Dr. Decarlo will be describing the results of his specific research and the scholarly articles that were generated as a result of their in-field efforts to quantify and qualify the composition of the pollutant emissions very close to the actual point sites where unconventional hydrofracturing is going on during 24/7 well drilling. In this segment, we'll be referring to the Marcellus Shale region located in the Commonwealth of Pennsylvania and in one of several shale regions throughout the United States, which are several, including Marcellus Shale region, the Ohio Shale region, the Dakota Shale region, and Texas Shale region, are some of the major regions where hydraulic fracturing is occurring. The Marcellus Shale region, which runs from the northeast to the southwest of the Commonwealth of Pennsylvania and underlies the Appalachian region of the United States, occupies 104,000 square miles. Dr. Peter Decarlo is a trained atmospheric scientist and as an associate professor in both the Civil, Architectural, and Environmental Engineering Department, as well as the Chemistry Department of Drexel University. Thank you for joining us, Dr. Decarlo. We're delighted to have you as our guest speaker this morning.
It's my pleasure to be here. Thanks for inviting me, and I'm looking forward to our discussion.
Dr. Decarlo, noted in your two scientific articles, you made air quality measurements in both 2012 and 2015 in the Marcellus Shale Basin. Could you describe these measurements and explain to our listeners why it is important to make these types of measurements in the Marcellus Shale Basin?
Sure. So the measurements we made from essentially a lab on wheels, which means we had instruments inside of a van taking real-time measurements, giving us real-time feedback on the concentrations of a variety of air pollutants. We measured methane, particulate matter, and other chemicals that we expected to see in the region. And the reason these measurements are important is they actually provide the real concentrations of these pollutant species in the atmosphere. And we need that information to better understand the emissions from Marcellus Shale facilities, the potential exposure to people in the region to these pollutants, and the potential impacts these pollutants might have on the environment.
What types of facilities were you making the measurements around? And secondly, how did you calculate the emissions from these facilities?
The 2012 and the 2015 studies were a little bit different in the way that we approach things. So I'm going to start with the 2012 measurements. And for those, we had two main measurement goals. We first wanted to measure the emissions from natural gas facilities, things like compressor stations, wells, and drilling activities. And the second thing we wanted to look at was the regional air quality impacts from the development of the Marcellus Shale. So what is the cumulative impact of all these different facilities on the regional air quality? So for goal 1, which was making measurements from these different facilities, we used a technique called tracer release. Essentially, what we do is we release a non-harmful chemical at a known rate near a facility, and then we drive our lab on wheels downwind of that facility, make measurements, and try to find where that we see that chemical. Since we know how much of that chemical we're releasing as a function of time, we know the release rate, we can then compare that to the concentrations that we see of the pollutants that are coming from that Marcellus facility, such as a well pad or a compressor station, and use that information then to calculate the emission rate of things like methane from that facility.
Your first measurements in the Marcellus Shale region took place in 2012. What motivated that study?
So it would have been great to have been able to make those measurements earlier. Unfortunately, I didn't start my faculty position until right around that time, and so that was the earliest I could make those measurements. But we chose that time and we got the study off the ground as quickly as possible because it was when the development of the Marcellus Shale was still in its relatively early stages. Things started out roughly in 2008, but it was a slow build-up. In 2012, things were really starting to pick up and development was really going quickly, and so there was pretty urgent need to understand what the atmospheric concentrations of things like methane and particulate matter were in the region. And so we made those measurements as quickly as we can to try to get that baseline understanding. And part of the motivation was that natural gas is often discussed as a cleaner power generation fuel than coal. But it doesn't always take into account what we call the upstream emissions. So if you think about just the power plant itself, natural gas has fewer CO2 emissions from a climate perspective than coal, but if you start to sum up the potential emissions from the natural gas coming out of the ground and being distributed and then getting to the power plant where it's burned, that difference might not be as great as just at the point of power production. And so we really wanted to understand what were the overall impacts of natural gas infrastructure, not just from where it's burned to make electricity, but also from the extraction and distribution portion.
Sure. So in 2012, when you started your collection, did the DEP have a baseline air quality measurement and greenhouse gas emission measurements from before the unconventional natural gas development?
Not really, and it's not necessarily the DEP's fault for not doing that. It's simply a function of the fact that most air quality measurements are done in urban areas. Air quality measurements are expensive to maintain, and the overall goal is to protect the people's health. And so the majority of people in larger populations live in cities, and so there are very few air quality monitoring stations in rural areas, and the natural gas development is happening in rural areas. So we have information on cities in that area, but we don't have information on the rural areas where we're really going to see the changes to the air quality from the natural gas development.
And I understand that DEP has actually lost over 700 scientists over the last 10 years, so that it didn't help the collection data.
That I'm not aware of that, but that seems like quite a few talented people to lose.
Representative Greg Vitale mentioned that in our last segment, last broadcast. So, I mean, it is a fact.
That's significant. That's a significant loss.
Exactly. Your follow-up study in 2015, was that also similarly motivated air quality and climate concerns?
The general goals were the same. The measurements were a little bit different. In 2012, we partnered with a company out of Boston called Aerodyne Research. In 2015, we did the study mostly by ourselves at Drexel with the instrumentation that we had. And the focus for the 2015 study was to look at emissions from pipelines as best we could and pipeline infrastructure. So it was a little bit different. We still looked at compressor stations, and we did look at a few well pads, but overall we were trying to gauge leakage from pipeline infrastructure. So slightly different focus, but similar measurements overall.
What was the biggest surprise or result from your measurement studies in the Marcellus Shale?
I think the biggest surprise was the increase in the methane levels we saw between 2012 and 2015. The level of increase that we saw was much higher than we expected or would have anticipated when we were looking at the emission inventory as maintained by the DEP. So if we look at the information the DEP collects, they sum up the methane emissions from all of the different industrial sources, and they report that to the public usually a couple years after the calendar year. And so between 2012 and 2015, if you look at what's called the emission inventory from the DEP, in the northeast section of the state, the DEP suggests that there's about a 30% decrease in overall methane emissions over that 3-year time period. When we made our measurements, what we saw was that the level of methane above the atmospheric background in 2012 was about 50 parts per billion. Above the atmospheric background in 2015, it was 150 parts per billion above the atmospheric background. So that's roughly a factor of 3 increase, or a 300% increase, which is very different than a 30% decrease. So clearly, between the measurements and the emission inventory, something is amiss. And I might be biased because I'm a measurement person, but I always trust measurements over models and emission estimates.
Surely. So you were saying that the methane emissions in the Marcellus drilling region are much larger than what the DEP reports actually did report in their annual reports that were circulated in writing. And you can't explain, do you have any ideas about why there's such a big discrepancy?
Yeah, so emission inventories are not perfect, and I think my 15 years of experience doing atmospheric measurements shows that most emission inventories are underestimates of what the actual emissions are. But they're useful in that they're the best way we have to try to keep track of different emission sources. So essentially what an emission inventory is a way to try to estimate emissions by, for the most part, in the Marcellus at least, counting the various pieces of equipment, knowing the leak rate of methane or other pollutants or release rate of pollutants from those types of equipment, and essentially summing all of that together. So what that assumes is that everything has a standard leak rate, things are well maintained, we're also accounting for all the equipment that's potentially leaking these things, and that's not always the case. So there's very often types of leaks that aren't accounted for. We know that things require maintenance.
Sure.
Cars break down, we have to get those fixed. It's similar to any kind of piece of equipment that you have to maintain. And so emission inventories generally are biased low, and so we don't we use them to try to track emissions, but we know that they're often flawed.
So this emission inventory, the reports detailing the information, how is this specifically compiled? I know you wrote two articles that I'm going to be posting on my link page so that anybody can go to them. As a courtesy, you're going to allow us to make them available to the public. But who reports the information, and again, how is the information compiled from like what you had gathered when you get the raw data? How do you compile that? How do you report? Did you report it to anyone or any agency other than put it into your scholarly articles?
So the emission inventory is actually compiled by the Commonwealth of Pennsylvania and the Department of Environmental Protection. So their role is compiling the information. But the information that goes in, that they're compiling, is largely self-reported by industry. And if you look at the emission inventory summaries on the PADEP website, there's actually a disclaimer that says, this is information that's self-reported by industry, essentially. And so they can't go and make measurements at every single well. They can't go and count all the pieces of equipment at the well, and so they rely on industry to fill out their emission inventory reports, and those all get summed up and compiled by the state, which is why there's about a 2-year delay between the end of the calendar year and the posting of the DEP. So August of 2017 was when the 2015 emission inventory came out.
I see. Are there any sources of methane that are not accounted for in the emission inventory, like you just mentioned, cars that need to be maintained, etc.? But beyond that?
Yeah, so in my opinion, one of the largest potential sources of methane that's not included in the inventory is from pipeline leakage. Mm-hmm. And I would say that's probably the most important source. And there's a whole range of different pipeline sizes depending on where they are in the natural gas system. There's about 7,000 miles of interstate pipeline in Pennsylvania. Wow. So this is pipeline that's, carrying a huge amount of natural gas to different markets through the state. We're adding to that from the Marcellus. That's well regulated. That's because that's such a large amount of natural gas moving through those. Those are actually regulated. There's also about 1,200 miles of intrastate pipeline. This is called Class 2, 3, and 4, and this is regulated by the Public Utility Commission. So this is all regulated, but this is all stuff within Pennsylvania. So smaller pipelines feeding into those larger pipelines, but still large enough that they're regulated. But there's about 12,000 miles of unregulated Class 1 pipeline that we know where some of it is. We don't necessarily know where all of it is. There's people who have looked into this issue. But these types of unregulated pipelines are certainly ripe for potential leakage. And we know that pipelines leak.
Sure.
There's a few years ago, there was that explosion in western Pennsylvania, which was, a leak from a pipeline, and it just had an ignition source. But it was a massive leak, and it became explosive. Smaller leaks aren't going to get to that level where they're explosive, but sure. We noticed when we were crossing pipelines, because most of the time roads do not follow pipelines, they just cross them. And so we looked at our data and found that about 20% of the time when we crossed over a pipeline, we saw elevated methane around that area.
I see.
That doesn't necessarily mean it was coming from the pipeline, right. But it's indicative that pipelines do likely leak.
We had a very, very bad explosion in New York a number of years ago. We had two, as a matter of fact. And the pipes do get old. And when you have vibration of heavy trucks going over them constantly, like you just mentioned in these transportation areas, these highways where you go across, it can't set it off. So it's a significant source of leakage. So taking a step back, could you explain to us why methane is important in the context of climate change and or our air quality?
Yeah, I'm happy to. So from an air quality perspective, methane isn't exactly one of the emissions from Marcellus that we're most worried about. It's not a health risk. If you inhale methane at the levels that we're seeing, mm-hmm. It's not going to cause any adverse health effects. Where it is a problem is if you're in an enclosed space and you get to a level where the methane concentrations are high enough where they can explode. That's certainly going to be a problem. But where it, from a global perspective, where it might be an air quality issue is that these increasing methane levels will increase global backgrounds of ozone. But methane has a very long lifetime in the atmosphere, so it's not going to be a localized increase in ozone. It's going to be more of a global increase. Where methane's really an issue is the climate perspective. Methane is a much stronger greenhouse gas than carbon dioxide. We focus most of our attention on carbon dioxide because it is much higher in the atmosphere. We've been measuring it for longer and understand it. But on a short-term or 20-ish year time scale, methane is about 56 times more warming on a molecule by molecule basis when you compare that to CO2. And so from a climate perspective, methane is pretty dangerous, and it's something we need to prevent from getting into the atmosphere. And there are these ideas that since it's a shorter-lived climate forcer, so it's shorter lived, it's about 9 to 10 year lifetime in the atmosphere versus the 100-year lifetime that CO2 has. If we target reductions in methane emissions, we might get more bang for a buck in the short-term mitigation of climate change. And so methane's pretty important on that from a climate perspective.
That's very interesting. So what you're saying is that methane is not a direct air quality health concern. Are there any other emissions or impacts from unconventional natural gas development in the Marcellus Shale region that could be causing health impacts to the residents there and throughout the state? As you mentioned, it gets downwind, it gets upwind, it gets into the wind stream, and it has a life cycle of 9 to 10 years in our atmosphere, our troposphere.
Yeah, so methane is, again, not the only emission from Marcellus Shale infrastructure. And so one thing that separates the Marcellus from some of the other gas and oil plays that you mentioned before in places like Texas and North Dakota and Wyoming and Colorado is that Marcellus, the geology of the underlying geology is such that it's mostly methane and ethane that's in the ground.
I see.
And we're not getting some of the associated VOCs like benzene and toluene that we're not getting the associated VOCs that you see in some of the other places like benzene and toluene that are known carcinogens. And this was a bit of a surprise in our 2012 measurements. We had a really nice instrument there to measure all these different VOC species, and we really didn't see a whole lot. Now, that being said, compressor stations and other infrastructure in the Marcellus Shale have the potential to emit things like NOx, which can impact ozone in the region. We saw ultrafine particle enhancements downwind of compressor stations, and there are the potential for other chemicals used in de-icing pipelines. We saw methanol in some regions that was used as an industrial chemical in some of these activities. So we didn't see a lot of some of the VOCs, but we definitely saw some of the other emissions like NOx, ultrafine particles. And there are some other studies that have shown potentially toxic chemical releases at sites, but we didn't, in our study, see all of those. And keep in mind, we're driving around, we're making a point measurement from a vehicle. We're not in the entire region at all times. So, we get what we see, but we don't necessarily see everything. And so if these are episodic, if they're just a release at a particular point in time, and we're not there to measure it, we're not going to see it.
I see. So the Marcellus Shale is not the only region in the United States where this the unconventional drilling is going on. Can you speak to the air quality and or climate impacts as compared to the other shale areas like we just mentioned, Texas, Ohio, even West Virginia, and the Wyoming area, North Dakota?
Yeah, so all of those areas are also experiencing this kind of boom in fracking and related extraction activities. The Bakken in the Dakotas is the source of some of the crude that the Philadelphia Energy Solution refinery has been processing. And so that area is going to have more emissions related to oil than gas, because they're actually pulling oil out of the ground there. In Wyoming and Utah and Colorado, the different areas have a different mix of gas versus oil wells. And there are some places, for example, in Wyoming, where some of the wells are oil and some of them are gas, just depending on where exactly you are in the geographic region. So the main thing that we consider when we're thinking about the air quality and climate impacts are whether the area is producing the oil or if it's producing the natural gas. Or if it's a combination, which one is being maybe vented as the waste product versus the one that they're trying to make money off of. The VOCs in these different regions are reactive and can lead to things like higher ozone. So what's interesting is in the Uinta Basin in Wyoming, they're actually seeing elevated ozone in the wintertime, which is very unusual.
I see.
Ozone is almost always a summertime pollutant, but in the Uinta Basin, the VOC emissions from the oil and gas operations are high enough that in the wintertime when there's snow on the ground, there's enough what we call photochemical activity, which makes the atmosphere reactive, to generate ozone, which actually exceeds the air quality standards for the US EPA. And so there are different places that certainly have much higher air quality impacts in addition to the climate impacts that we expect.
Well, it sounds like there are still a lot of unknowns regarding the environmental and health impacts of fracking in the United States. Are you preparing to conduct any additional measurements in the Marcellus or elsewhere?
Yeah, I mean, we would absolutely love to continue to make monitoring measurements in the Marcellus Shale to better understand the trajectory of the emissions, understand the air quality as things progress, and also the climate relevant emissions. As with all research projects, though, we need to find a source of funding.
Sure. Typically,
we look to the federal government to fund a lot of our research activities. Sometimes we get funding from foundations or other research institutes. Our first study, for example, was funded by the Electric Power Research Institute. With the current administration, it's unlikely that there's going to be a large priority on looking at air quality and climate impacts. So while we would love to continue this research, we're still looking for kind of the funding to back that.
What role should industry play in the reduction of emissions of methane from the drilling and the distribution of natural gas in the Marcellus region?
I personally think industry has a strong role to play, and they should play that role. The loss of methane represents a loss of product. It's one of the things they're trying to sell to the market, and so reducing leakage is something that, in theory, could help their bottom line, and it's pretty easy to make that economic argument. I think the issue seems to be with how leaks are identified in a timely fashion. Do they have the ability to fix them quickly? And do they have the measurement capabilities to do that? And there are some of the larger companies are implementing methane leakage programs to try to reduce their emissions and identify those leaks earlier. But again, there are things like pipelines are really hard to identify and fix. If they're underground, it's not a direct leak that's big. It often gets distributed, and you might see a slight enhancement, but you're not going to be able to identify that quickly or fix that quickly. There does seem to be some reluctance of industry to have regulation in place that forces this behavior. They've been blocking stricter methane regulation that's at the state level, and so it appears that they might be amenable to kind of a voluntary effort, but they don't seem to be willing to let regulators identify how they should or could fix these problems. And so that's something that I think, clearly needs to be discussed.
Are there any ways that you can think of that the Commonwealth of Pennsylvania should be addressing these environmental impacts in a more comprehensive way?
Yeah, I mean, I think you asked the question earlier if there were baseline measurements, and the answer was know, because we typically make air quality measurements in urban areas to protect the larger populations. But with the industry growing the way it is, with the money that's coming in from taxes and fees for companies to operate, I think the state has a responsibility to send some more of that funding into better monitoring of the environmental impacts of the natural gas industry, establishing more monitoring networks to understand the methane levels in the atmosphere. It seems like the resources that they're getting from the industry should be used to monitor the industry. And so there have been some efforts to do that, but it seems like the particular pollutants that are being chosen to be monitored, for example, they wanted to measure overall particulate matter in this region. That's a non-specific pollutant to Marcellus shale development. It's definitely something we care about from an air quality perspective, but there are so many different sources contributing to particulate matter, and what we saw was in our measurement studies is that's not the pollutant that you really want to use to track the emissions from the industry. And so it would be better if there was a more comprehensive look at what are the most important pollutants to measure, and then building a monitoring network in the region where Marcellus shale extraction is occurring to really get an idea of what are the emissions, the environmental impact, and the human exposures.
Sure. And this would involve more study.
Yes.
Probably a lot more study. The extraction of natural gas from the ground is only part of the process of using natural gas. Are there uses of natural gas that also pose risk for leakage of methane to the atmosphere other than the pipelines? You had mentioned the cars that need to be repaired and may be left for a while before they actually are, or other vehicles.
Yeah, I mean, so basically any point once you take the methane out of the ground and before it's burned in its end use presents an opportunity for leakage of methane to the atmosphere. Pipelines are used at various stages. They move gas to storage facilities, and then from those storage facilities into major pipelines to markets. Once they get to a market, they can also be distributed. City infrastructure, City of Philadelphia, has very old infrastructure. We have some of the earliest natural gas infrastructure in the country, and a lot of it's cast iron, a lot of it's bare steel. These things corrode, and once you have a hole in a pipe, it's a leakage point. And so we have roughly 2,000 miles of old natural gas pipe that is prone to leakage in the city of Philadelphia. Measurements have been made in other older cities, Boston and Washington, D.C., with old infrastructure, and they have shown a pretty large amount of methane leakage due to the old infrastructure. And so we've done a few basic pilot measurements in Philly at a senior design group at Drexel, looked into this a couple years ago, and we've seen similar leak rates. And so we have something like 2 leaks per mile is what we saw in our relatively small pilot study. This is similar to what was seen in Boston and Washington, D.C.
So in terms of power production, natural gas power plants are replacing coal power plants. Can you discuss the air quality and climate impacts of natural gas versus coal for power production?
So we see a lot in the media that natural gas is better than coal. We also see the president saying that he's going to bring coal back, but even with that being the case, we're not seeing anyone moving to build new coal-fired power plants. I think the low cost of natural gas as a fuel and the lower cost to just build a natural gas combined cycle power plant are 2 reasons we're not seeing coal come back. Coal is inherently a dirtier fuel. It's a solid fuel. It has sulfur in it. It has heavy metals.
Sure.
It actually is the largest source of radioactivity to the atmosphere from any of our industrial activities, more than nuclear power plants. And so it requires coal requires much more air pollution control equipment to reduce the emissions of particulates and other gases, including mercury and heavy metals. So from an air quality perspective, natural gas is certainly better than coal for power production. CO2 emissions per kilowatt hour, megawatt, or gigawatt of electricity are also higher with coal. So coal not only emits more air quality relevant pollutants, it also emits more CO2 per unit of power that you generate. Now, when you account for the leakage of methane that we've been talking about here, that might not quite be the case. If you leak about 3% of what we take out of the ground, then that erases the climate benefit of natural gas over coal.
Sure.
From a natural gas versus coal perspective, natural gas is clearly better from an air quality perspective, but I think the jury is still a little bit out on the climate perspective.
Well, are there any other issues that haven't come up during this discussion regarding the natural gas development and related infrastructure that we haven't had a chance to talk about, that we should talk about, that the public really should know about, our listening audience should know about?
Yeah, I kind of want to continue what we were just talking about and mention that, you know, we're always presented with a coal natural gas decision, but we don't always think about things like nuclear or renewable energy as and how do those stack up. And when you look at, you know, climate relevant emissions, methane or CO2, nuclear emits virtually none.
Sure.
Wind emits none. Solar emits none. Right. Hydro emits none.
Right.
From an air quality perspective, nuclear emits none.
Right.
Hydro emits none. Solar emits none.
Right.
Wind emits none. And so if we keep talking about coal versus natural gas, we miss out on the fact that there are other ways of generating electricity that don't even have this problem. And setting up this false choice between coal and natural gas without considering the other alternatives is something that is a little bit frustrating when I see that the other opportunities for reducing our climate emissions aren't even discussed.
Many of us would agree with you, and we actually do need to broaden the discussion and the public awareness. In near-term segments, I'm going to be talking to other researchers and experts in these other alternative, green, sustainable, domestically sustainable technologies where we don't even have to have the discussion about methane or CO2 or these other SOx, NOx, plus the filth, the dirtiness of the fuel itself, the radiation, the radon and radon daughters in the mines after the coal is removed. That's the off-gassing from removing the mineral from the mine. So, Dr. Decarlo, are there any other projects you're working on that look at some of the climate and or air quality impacts in the area or elsewhere in the Commonwealth?
Yeah, we have lots of projects ongoing, most of them in some way, shape, or form related to climate. One kind of exciting local project that we have going on is a collaboration with folks at Penn in Penn's program in environmental humanities in Bartram's Gardens, and we have this multidisciplinary approach looking at the Lower Schuylkill River from a scientific, a human, and an ecological framework, and a historical framework as well, and try to understand the development that has gone on there, especially the refinery is kind of a focal point of a lot of those discussions, and understanding how that fits into the larger picture, and really coming at it with a bunch of different people from different disciplines and seeing how all these different perspectives can come together and paint kind of a larger context and picture. I currently have two folks from my research group in Nepal right now looking at air quality and particulate matter measurements in particular. This is a follow-up to a study we did in 2015 when we were there. Unfortunately, the earthquake in 2015 prevented us from finishing those measurements, and so we're there now to try to get a better handle on some of those South Asian emission sources. And from a climate perspective, the the particulate matter, in particular black carbon, is one of the larger climate forcers after roughly on the same scale as methane. And it's something that we need to better understand the emissions. And so that's one of the reasons we're in Nepal and making those measurements. So we're staying busy, trying to do what we can.
Would you like to add anything here or make any comments that might be helpful to our listening audience that may help them feel that they could do something or feel empowered to try to help mitigate the greenhouse gases or mitigate anything to do with, as we just discussed, the methane drilling that's going on virtually all over the state?
I mean, I think my advice for people who want to do what they can for climate is, look carefully at what your potential carbon footprint is, and in your everyday activities, figure out ways that you can try to reduce that. From a larger perspective, stay informed, vote. A path to a lower CO2 footprint starts with people advocating and requesting a transition from fossil fuel use to generate electricity or for transportation, and doing what we can to promote carbon-free electricity generation, whether it be nuclear or renewables, and also electrification in transport. So it's nice that SEPTA's trains are all powered by electricity. Vehicles, cars, if those are powered by electricity, then you don't get the tailpipe emissions, right? Sure. Those emissions are happening pretty far outside of your city and town, and so you're going to get a massive benefit from air quality in an urban area if people start transitioning to electric vehicles as well. So these are things that, sure, if we have the means or maybe the motivation to start electrifying and generating power that doesn't rely on fossil fuels, it's a way to both improve air quality and to protect our climate.
We did hear from one of our other researchers. He'll be talking about his mentoring with his honors students, Dr. Gurian, and they have made recommendations to the university, and I know there's a plan in effect to try to phase out the buses, the shuttles that we have, and change to an electric vehicle. So that's that will be a big step in the right direction, just in the immediate university city area.
That would be great if Drexel could lead some of those transitional.
Exactly. Well, Dr. Decarlo, thank you so very much for coming and taking time out of your very busy schedule. We really appreciate it. We've learned a lot today, and I will post the links on my link page on my website, and also the PEAD. I will give a link to that so that our listeners could learn a little bit more about that if they would like to know more. Knowledge is power, and it makes us smarter voters when we have the information, the scientific facts, and the information at our fingertips.
Yeah, no, we are, both of the articles that we published on the Marcellus Shale are open access, so they're not behind a paywall. We want anyone to have access to them, whether they're a scientist or just a general interested person.
They will be posted. I'll post the links to them. And we thank you very much for your contribution, and it was very, very stimulating and very informative. Thanks again.
Thank you for having me.
Thank you.